Hello everybody, this is Bika Ramesh and I am explaining part 2 of the 7th assignment. For part 2, we've already been given a few files, that's the attribute file, library file, info file, blib and flip files, and the sobel.c file. So in the sobel.c file, it performs the sobel function where it extracts the outlines of an image. It uses these attributes. So there are different attributes that can be formed. So the choices for each attribute is varied as shown here. So the total number of combinations that is formed here with the choices are around 192. So we have to run a script where the sobel.c file chooses all the 192 combinations that can be taken by the attribute file and it runs, and it uses these two library files and it gives 192 quality of report outputs. So I run this script to generate those. So we get output combinations for different combinations. So the first one, there is one attribute file and the corresponding QOR file. Then for the second one, we have an attribute file and a corresponding QOR file. So say in the same way, there are 192 files present here. So the script also runs in such a way that from these combinations, a final .csv file is also generated. This CSV file I downloaded into Windows and then copied it here, and I got it here for different combinations. Next, after this, I ran another script, script6.py, and I run the script from this data. It plots a graph. I'll show you how the graph gets plotted. Terminal, and run the script. So this is the graph that gets plotted. So on the y-axis we have area ALUTs, x-axis there's latency. And the blue points are the combinations, all the 192 combinations that's present here. The red is also one of them, more than one of them, sorry. So there are some which get repeated and are placed in the same points. As you can see, there are no 192 points here. There are some in the same space here. So here, this is the most optimal point because this has the least latency, which means faster and higher execution, and the least area, like a smaller chip. So we have to derive the pragmas or the combinations that is used for this optimal solution. So in the Excel sheet, we found that the least latency was 1. So finding the least latency of 1, we derived the different areas and the latencies, which of the least, that is 175 ALUTs and 1 nanosecond as the latency. We found 16 combinations. These 16 combinations are the most optimal pragmas which can have the least latency and the least area.